Hey George, how you doing? Looks like just you and me, and I'm starting part 2 of the Cycle 3 review. So, for anyone that's watching on YouTube or the videos on YouTube, this is part 2 of the Cycle 3 review, and the test has been posted for Cycle 3. And I'm going to do a little bit of the part 2 review, and I actually added more documents down here of a lesson that I hope will help recap some more stuff. So I'm going to go over this kind of quickly. So I wanted to first go over a few things here. So vertex form, if you recall, vertex form is this equation right there. And the letters represent something. So mainly what we're concerned with is, what do the letters represent? And we're concerned mainly with these ones right here. And so I'm going to go like this. So with vertex form, the key things that we're looking for are A, H, and K. And so A represents this step pattern. And that's kind of the true case for anytime you see a trinomial, anytime the number that's attached to the x squared is the step pattern. And then the next part that we're concerned about is the coordinates for the vertex, which are right here. The x and y coordinates for the vertex of the parabola, right? Except with one tiny asterisk, which was that the x is the opposite value. Because x is a liar. X is always the opposite of what you think it is. So, for example, and y never lies. So if I were to give an example, once I can actually get my screen to roll up here. So let's do an example. If I had y equals 2x minus 3 squared plus 7, the step pattern would be positive 2, and the vertex would be at these coordinates, 7, because y never lies, and then 3, because x minus 3, it's positive 3 here, so it's the opposite. Right? So that vertex would be at 3, 7 with a step pattern and positive 2. Now we could do the opposite as well. So let's look at this equation, or this parabola we have right here. So we have the vertex at this point right there, and the coordinates of that, we do the x first. Remember, the x is the side to side, and the y is the up down. So the x is in this direction, it's 3. And then how far down are we going? We're at negative 4. So there's our vertex right there. Next is the step pattern. So to do step pattern, we're concerned with going over 1. We go over 1, and how far up or down do we have to go before it meets the parabola? So in this case here, we're going up 2. So if that's our step pattern, we can say that therefore the equation is y equals, we put our step pattern in first, 2, and then we do x, and then, so the x value is 3, it's positive 3, so the x value we'd put in is x minus 3, the opposite, squared, and then the y value would just stay the same, minus 4. And there's our answer. All right, let's look at the part below. So this time we're given an equation. Let's add that one to the graph. So here we have our step pattern, and we have a vertex. Based on this point here and this point here. So we know y never lies, so it just stays at 4, but x is a liar, so it's the opposite, -2. And our step pattern is -1.5. So let's find the vertex 4 first. So we go to -2 and 4. There's our vertex. And then we're doing our step pattern at -1.5. So over 1, down 1.5. Right about there. And it goes to both sides. Now, I would be happy with just you even doing this. If you give me the one step and the vertex, I'm pretty happy. If you wanted to go the extra mile, you could give me the next step. And if you recall, finding the other steps is you take the standard step pattern and you multiply it by that first step. And we're going to get a whole bunch of different values here. So we got -1.5, -4.5, -7.5. So that's how we could find the next steps. So if this one was here is -1.5, the next step over would be 4.5. So we go over once and then down half, and then we count 4. So we'd go 1, 2, 3, 4, right to this point right there. And it's symmetrical, so it would also be on the side right there too. So we could continue the parabola if we really wanted to be accurate and go the extra mile and say it goes like this. But I'm happy with just showing the one step. All right, let's move on. What about in factored form? So the difference with factored form was it's in that form where it has kind of the two brackets like this. There's no squared term, right? It's just the binomial with an a value out front. So again, the a value, just like before, represents the step pattern. And then factored form, what it does is it gives you the x-intercepts, otherwise known as the roots or the zeros. All right, so we have to remember again that x is a liar. That's the one last thing. So we're going to remind ourselves. So these values are opposite. So for an example then, if we have an example like y equals 2x plus 1, x minus 3, we would say that the step pattern is 2 plus 2, and then the x-intercepts are at x equals -1 and +3, right? Because they're the opposite. All right, so let's look at a couple of examples here. So let's find the equation of the parabola we have here. So again, we could look at, we have an x-intercept right there, and we have an x-intercept right there, because that's our x-axis. Here's our y-axis. So we have x equals 3 and x equals -1. So if we have that, that means that our equation is going to be y equals something, like the letter A. We're going to use as a placeholder until we figure it out. And it was x minus 1, so it's x plus 1 here. And the other one was x plus 3, so it's x minus 3, like that. And if we look at our A value, we can look at it and determine it, again, over 1, up, half. So our step pattern is half. So the A value is actually 0.5. And that's the equation of our line. So this last part here says I can explain when it is better to use vertex form for a parabola and when it is better to use factored form. So factored form is better when you know the x-intercepts. So vertex form works better when you know the vertex. Basically, likewise. Let's look at a couple more examples because that was too quick. I'll stick with the parabolas for a second. Let's go down to more of my parabola questions here. All right, I really like this question here. This is kind of putting it all together. All right, so we have a parabola that's right here, and it is in vertex form. So we can start off by saying we know that the vertex, we have a step pattern is equal to 2, and a vertex at +3 because it's the opposite, and y never lies, so at -2. So if we were graphing that parabola, we could find the vertex first. There's our vertex. That's 3, -2. And our step pattern was 2. So we would go over 1, over 1, up 2. On both sides. And just by looking at that, we can actually still find we can say what the equation is in factored form because we can see what the x-intercepts are. The x-intercept, because it's going through 4 and 2, it would actually, and we already know what the step pattern is. The step pattern was 2, so we could end up going like this. Y equals x minus 2, x minus 4. And that's the exact same equation. So it's a different equation than the vertex form, but it has the exact same, describes the exact same parabola. So sometimes the same parabola can be described from the equation in different ways. And we can actually get there by using expanding and factoring to get there. But you know what? I don't want to overcomplicate it, so I'm going to leave that one alone, actually. Let's do a couple last examples. Point of intercept as a reminder. So this is on the test for sure. It was one of the lessons we did. Point of interception or intersection. So we use something called substitution, right? So we let y be equal to y. So that means this section here has to be equal to that. So 2x minus 3 is equal to -4x plus 9. And then we just wanted to get all the x values on one side of the equation. So let's get rid of this guy and bring it over there. So we would end up with 2x plus 4x. And I'm going to take this -3 and bring it over to that side. So +9 plus 3. And we can simplify that when we get 6x equals 12. And once we're at this step, we just have to get rid of the coefficient, the number beside the x value, the variable. So we're going to divide by that. And whatever we do to one side, we must do to the other side. And we end up with x equals 2. Because 12 divided by 6 is 2. So now that we have an x-coordinate, we sub it into either equation. So if I pick the first one, like y equals 2x minus 3, y equals 2, and we're going to put that value in. Two times 2 is 4, minus 3, y equals 1. All right, so now we have the x and y, so we could say, therefore, the point of intersection is our x-coordinate and our y-coordinate. And that's it. Here's a really easy one. What is the step pattern and vertex of parabola with this equation? Well, our step pattern is always the number out front. And the vertex are these two right here, except x is a liar. So it becomes 3, negative 4. All right. I think that covers mostly everything that we could possibly want. I'll recap again. No, you know what? I think you guys already got that. We don't need to go over that too many times. And rearranging. I'll do another quick little rearrangement, actually. So if we look at this one right here on the left, I want to rearrange it into this form, y equals mx plus b. So I want to get this 6y. I got to get it away from everything else. So what I'm going to do is, you know what, I'm going to bring the 6y and I'm going to bring it to the right side of the equation. That will leave it separate. So we would end up with 13x plus 39 is equal to 6y. Now I want to get rid of the 6 because I don't want it all over the place, because I have to get rid of any coefficients here. So I will divide it by 6. And that will cancel that one out. So we will be left with like this. Or we could rewrite it like this. Y equals 13 over 6x plus 39 over 6. Now, technically, we could reduce that 39 over 6 because it would be 6.5, 6.5. So we could have actually written it like this. Y equals 13 over 6x plus 6.5. But either one of those answers is correct. Let's do the other one right quickly. All right, we got this one right here. And again, we want to get y by itself. So, you know, y is already positive right now. So let's just get rid of the negative 16. I'll use the other method this time. The method where I just go like this. If I want to get rid of that 16, I'll add 16. Normally, you just see me writing it over there. That's kind of my usual thing. But you could do it this way too. And so I'd be left with 2y is equal to 4x plus 16. Now I want to get rid of that 2 that's attached to the y. So I will divide it by 2, and I have to do that to every single term. And I'm left with y equals 4 divided by 2 is 2. And then 16 divided by 2 is 8. And there's our answer. All right, there's a couple questions that are like that on the test. It's not too long. I think there's about eight questions. If anyone has a question on they're struggling how to do it, again, you don't have to complete it all in one sitting. You can come back and watch the videos. You can send me a message. It's really entirely up to you how you want to do it. And yeah, that's pretty much it for today. Any questions, George?